You know the scenario. I mean, it's the absolute staple of every time travel movie ever.
Oh, yeah.
You jump back to the Jurassic, you're trying so hard not to touch anything, and then snap, you step on a bug.
It's just one tiny bug.
You rush back to the present and everything's wrong. The spelling of words is different, or, in the really famous example, a completely different person is president.
The classic butterfly effect.
Mm-hmm.
It's the ultimate be careful what you wish for story, isn't it?
It's terrifying. The idea that one tiny mistake could just erase your reality. But, and this is why we're doing this deep dive, it turns out that version, it's mostly fiction.
It is, yeah.
But the actual science behind it, the stuff with chaos theory and weather, it's honestly even weirder.
I think weirder is exactly the right word. Because when you dig in, you find the butterfly effect isn't just about time travel. We're going to be talking about supercomputers, quantum physics, and even corporate accounting.
So that's our mission for today. We're going to dismantle the Hollywood version, let's call it the Bradbury version. And then we're going to build up the real scientific principle, the Lorenz version.
And we've got a really interesting stack of sources for this. We have Ray Bradbury's original short story, of course.
A must.
Then we have meteorological history from UCL and NOAA, some pretty dense philosophical essays, and then cutting-edge research from Los Alamos National Lab and a financial study.
It's a lot, but I want to start with the fiction. Because honestly, I still want to know if I can go back and fix my high school yearbook photo without breaking space-time.
Well, let's see. We have to start with the origin. What most people think of as the butterfly effect comes from one story. Ray Bradbury's A Sound of Thunder.
I read this in school, but the details are so much more specific than I remembered.
They are. Bradbury imagines this company, Time Safari Inc.
Right.
And they take rich guys back in time to hunt a T-Rex. But the rules are incredibly strict.
They have that floating path, the anti-gravity metal path that stays 6 inches off the ground.
And the guide, Travis, is obsessed with it. Don't step off. Don't touch a single blade of grass.
And his reasoning is basically chaos theory before it was even a thing.
It is. He gives this whole speech, kill one mouse, you starve a fox that starves a lion, and suddenly all of human history is different.
It's like the ultimate domino effect. And they even try to avoid a paradox with the dinosaur they're hunting.
Yeah, they've scattered ahead. They know a tree is about to fall and kill that specific T-Rex anyway.
So they shoot it seconds before that happens. No harm, no foul.
In theory. But then you have Eccles.
Oh, Eccles, the guy who ruins it all. He sees the T-Rex, he freaks out, and he just runs off the path.
Panics completely. He gets back to the time machine, they go home. Things are just off.
The air smells weird.
The sign on the wall is still drawn.
Yeah.
And the big one. The moderate candidate, Keith, had won the election when they left.
And when they get back, a dictator named Deutscher is in power.
And then comes the big reveal. Eccles sees some mud on his boot.
And there it is, a single, beautiful, crushed butterfly.
One dead bug, and democracy falls.
But this is where we have to pump the brakes, because the source material we have from Mind Matters really picks this apart.
It does. It raises the logic gap question.
Yeah, like why a different president? Why not humans with 6 fingers? Or why isn't the sky green? The connection feels so arbitrary.
That's the argument. The story gives you no map. How does A lead to B 60 million years later? It implies the timeline is this fragile little thing where every single piece is load-bearing.
But isn't that the whole point? And everything's connected.
Connected, sure. But in a truly complex system, small changes usually get absorbed. An ecosystem adapts. The idea that this one signal, the dead butterfly, would stay perfectly coherent for millions of years and flip an election is, well, it's great fiction.
Not so great science.
Not really. And the critique also mentioned the mud. Eccles didn't just kill the butterfly, he brought primordial soil back.
Oh, right. The guide was almost more freaked out about the bacteria than the bug itself.
But pop culture loves a poetic image.
Speaking of pop culture, we have to touch on the Ashton Kutcher movie.
Yes. The Butterfly Effect from 2004.
Which takes this whole idea and just runs with it, turning it into this psychological horror.
It's a completely different take. Instead of hunting dinosaurs, the main character, Evan, is going back into his own past to fix childhood traumas.
It's the ultimate fix-it fantasy. Except every time he fixes something, he makes everything else 10 times worse.
Exactly.
Yeah.
He saves a dog, his friend becomes a murderer, he saves the friend, he ends up losing his limbs. It's just this cascade of unintended consequences.
It's bleak. But I had never seen the director's cut ending, and our notes mentioned it. I looked it up, and Wow.
It is probably one of the darkest endings in all of science fiction.
So in the normal version, he just makes it so he and his girlfriend never meet, right?
A sad but noble sacrifice. But in the director's cut,
He realizes that he's the problem. He is the initial condition causing all the chaos.
so he goes back, all the way back, to the womb.
It's just wild.
He travels back to when he was a fetus, and he strangles himself with his own umbilical cord.
Wow. Talk about removing the variable.
It's horrifying, but it's the perfect encapsulation of that Bradbury-style universe. The timeline is so fragile that the only way to save it is to just not exist.
Okay, so that's the Hollywood version. The universe as a delicate glass sculpture. But the real science came from a guy who was, what, just trying to predict the weather?
Edward Norton Lorenz. And yet the story is so mundane, which is what makes it great. It wasn't some grand adventure. It was just a slow afternoon in a lab in the 60s.
Science happening because somebody wanted coffee. I love it.
Literally. So Lorenz has this computer, a Royal McBee, big, noisy vacuum tubes everywhere.
Okay.
And he's running a long-term weather simulation. He wants to rerun a section of it, but he doesn't want to start all the way from the beginning.
Right, because it would take forever on those old machines.
So he just takes the numbers from a printout from the first run, types them back in to start from the middle, and goes to get his coffee.
Seems logical enough.
He comes back an hour later, and the new graph.
Yeah.
It's gone completely haywire. It starts off matching the old one, but then it slowly starts to drift away.
And then the drift gets bigger and bigger.
And by the time it gets to 2 simulated months, the weather pattern is totally different, unrecognizable.
But wait, he typed in the same number.
He thought he did. And this is the whole discovery. The computer, in its memory, stored the number to 6 decimal places, like 0.506127.
Okay.
But the printout, just to save space, rounded it to 3 places, 0.506.
That's it. The difference was that tiny fraction.
That was it, a rounding error of less than 1 part in 1,000. Lorenz thought it would be meaningless, but in the system, that tiny error just grew and doubled again. That is, sensitive dependence on initial conditions.
So in Bradbury's story, the butterfly kills the president. In Lorenz's world, the rounding error moves the hurricane.
Perfectly put. And here's a fun fact. Lorenz never originally used a butterfly.
No.
His first metaphor was a seagull. He said, one flap of a seagull's wings would be enough to alter the course of the weather forever.
The seagull effect doesn't have the same ring to it.
Not at all. The butterfly came from a title suggestion for a talk he was giving in 1972. Does the flap of a butterfly's wings in Brazil set off a tornado in Texas?
Okay, I have to ask the question that always bugged me about this. Does the butterfly actually create the tornado? Is that little puff of wind traveling all the way to Texas?
No, and that is the absolute key distinction. The butterfly isn't the power source.
Right.
The atmosphere is already unstable. It's full of energy. Think of it like a huge boulder balanced right on the edge of a cliff.
The energy is in the boulder, waiting.
Exactly. The butterfly is just the tiny push that makes it fall to the left instead of to the right. It determines the path of the chaos, not the power.
Which leads to a huge philosophical question. If everything is that sensitive, can we ever really predict anything?
And that takes us to Laplace's demon.
Sounds like a prog rock band.
It's a thought experiment. A scientist named Laplace suggested that if some super being, a demon, knew the exact position and momentum of every atom in the universe,
Every single one.
it could calculate the entire future with perfect accuracy. Because it's all just cause and effect.
Like cosmic billiard balls.
But our source on determinism introduces this counter idea that I find kind of chilling. They call it the enemy from within.
The enemy from within, that's ominous.
It's the idea that true initial conditions go down to a microscopic level we can never see. The example they use is striking a match.
Okay, simple enough. You strike it, it lights.
Most of the time. But maybe 30% of the time it just fizzles or breaks. Why? You use the same force. The conditions looked identical. The enemy is the invisible microscopic arrangement of the chemicals on the match head, or a tiny fracture in the wood. The macro looks the same, but the micro is different.
And that micro difference causes a macro failure.
Exactly. And my favorite example from that reading was about the gin and tonic.
Yes, this is where physics gets really weird.
So the laws of physics say if you stir a gin and tonic, the ice melts. But theoretically, it's not impossible for all the molecules to be aligned in such a way.
A conspiratorial way, I think they called it?
Yes. A 1 in a trillion chance that stirring it could actually make the ice cube grow bigger.
That feels like breaking the rules of the universe.
It's compatible with the laws of motion. It's just so statistically unlikely it will never happen. But in a chaotic system like the weather, those microbutterflies don't cancel out. They grow. And that's why we have a predictability horizon.
Which is why my weather app is basically guessing about next Saturday.
It's not guessing, it's just losing the fight. The tiny errors in our measurements double every few days, so a 2-week forecast. The error has grown so big, the prediction is essentially random noise.
So we're stuck. We can't really predict the future. We can't fix the past. But then the script flips.
Yes, the big twist.
This research from Los Alamos National Laboratory, it basically says, hold on a second, the universe might have a fail-safe.
The quantum anti-butterfly effect. This is where it gets truly mind-bending.
So walk me through this. They didn't have a time machine. They had a quantum computer.
Right. Researchers simulated sending a qubit, a bit of quantum information back in time, using a complex logic circuit.
Okay, so they have their time-traveling qubit.
Then they stepped on the butterfly. They deliberately damaged it in the past, messed with its information.
So based on everything we've just said, when that qubit comes back to the present, it should be a total disaster. The damage should have amplified.
That's what everyone would expect. But when they measured it, the information was fine. It had healed itself.
How is that even possible? You can't unscramble an egg.
In our world, no. But
Yeah.
in the quantum world, you have entanglement. Think of it this way. In the classical world, I write a message on one piece of paper. If you burn that paper in the past, the message is gone.
Chaos, right.
But in a quantum system, that information isn't just on one piece of paper. It's entangled. It's smeared out and correlated across 1,000 other pieces of paper. The information is distributed.
Oh, I see.
So if you burn just one of those papers in the past, the network still holds the complete message. When you come back to the present, the system reconstructs the missing piece.
It's like a cloud backup for reality.
That is a perfect analogy. The conclusion was that at this fundamental level, reality is self-healing. It actively resists the butterfly effect.
So we have chaos on top in the big weather systems, but deep down at the quantum level, there's stability.
It seems that way. The universe builds complexity, but it also has mechanisms to preserve information. It doesn't want its own history to be rewritten.
Okay, so nature has this built-in stability, but now I want to pivot to a system that feels like it has none. A system built on human chaos business.
Ah, yes. The financial world.
We've got this study on the Muscat securities market about something called earnings management. And reading it, I realized these executives are flapping the butterfly's wings on purpose.
That is a great way to put it. Earnings management is when managers make these little tweaks to their financial reports to make things look smoother than they are.
Using discretionary accruals, which is just a fancy way of saying they're fudging the timing a little.
Exactly. You're going to miss your quarterly profit goal by just a little bit. So you push a big expense into the next quarter, or you recognize some revenue a few days early.
Tiny little adjustments. Small wing flaps to make the short-term numbers look good.
But the study found that those tiny short-term flaps create a long-term tornado. They completely destabilize the company's future performance.
It tanks their return on assets.
Drastically.
Yeah.
They found that the more a company tried to smooth its earnings today, the more volatile and poor its performance was tomorrow. By trying to hide the chaos, they just created a bigger crash down the line.
It's like building a dam. You stop the river's natural flow to create a calm lake, but you're just building up pressure that will eventually break the whole thing.
Exactly. And the study found a really key difference between large firms and small firms.
Let me guess. The big companies can handle it better.
They can. Large firms are more like that quantum system. They have more resources, better governance, more entanglement to absorb the shock.
But the small firms are like Lorenz's weather simulation.
Yes, they don't have that buffer. For a small company, those little accounting tricks can spiral out of control really, really fast.
So the lesson for anyone in business listening is, don't try to fight the chaos.
The lesson is that pretending things are stable when they're not is incredibly dangerous. It's better to navigate the real choppiness than to create an artificial calm that's hiding a coming storm.
It's amazing we went from dinosaurs to quantum computers to corporate finance, but the thread through it all is this illusion of control.
It is. We want to believe we can fix the past or perfectly predict the future or guarantee our quarterly earnings.
But the real lesson of the butterfly effect isn't about time travel, it's about humility.
It's Lorenz's lesson. You can know all the rules, all the laws of physics, but you can never measure the present perfectly enough. There is always a rounding error, always an enemy from within.
And yet, there's that quantum research, that glimmer of hope.
The self-healing universe.
That's the thought I want to leave everyone with because it's been buzzing in my head all week. If the quantum world is fundamentally self-healing, if it resists the butterfly effect, does that mean the universe protects its own history?
It's a really comforting idea that on some level reality is robust.
But then I think about us, humans. We're not quibbits. We're big, messy, chaotic things. We're the ones managing earnings and changing the weather. So here's the question. Are we part of that self-healing system? Or are we the one thing in the universe that's just too big for the backup to fix?
Maybe that's what makes us so unique. We might just be the only true agents of chaos in an otherwise self-correcting cosmos.
Well, on that slightly terrifying thought, be careful where you step today. Thanks for diving deep with us.
See you next time.